that's intersected by a line, so it has two solutions. Okay, so this would have two solutions. I might have a quadratic intersected by one line, so it could have one solution. Just depends on what's going on. Or I could have a quadratic and a line, but they never cross, so this would be a no solution scenario. And then lastly, you could have two quadratics intersecting this way. This would also give you two solutions. Okay? So what you're doing today is you're going to be finding however many solutions you need to find. Okay? So sometimes it's two, sometimes it's one, sometimes there's no solution. They don't actually cross at all. And sometimes there's two solutions. So you're going to know that by graphing it. Today I'm not giving you any no solutions, but I just want you to visualize what's happening as we algebraically solve for these intersections. Alright, in 10.2 we're going to talk about systems again, but this time we're going to mix it up. It's going to be quadratic and linear equations together. We haven't done them like this yet. And the reason I'm doing it on paper is so I can show you some calculator ways to check your work. So let's look at this. If I'm solving by substitution, I can then look at both these equations are y equals, right? So that means I can just set this guy equal to this guy and go from there, and you'll see how this works. So watch this. If I do x plus 6 equals negative x squared plus 5x plus 6, I want to have my lead exponent to be positive. So I'm going to move this guy over here, and I'm basically going to move everything over because I want it to be set equal to 0. Start with that. So if I move all this over, I'm going to have a positive x squared plus minus 5x minus 6, and then I'm going to rewrite what I have there, plus x plus 6 equals 0. Now I combine like terms. I have my x squared, done with that, minus 5x plus x gives me minus 4x. Then I have minus 6 plus 6, well they go away, so now it's set equal to 0. And I can solve this. So thinking about GCF, I take an x out of both. I have x minus 4 equals 0. So then I set each part equal to 0, x equals 0, x minus 4 equals 0. That means x is 4. Alright, that's part of my solution, but I need the y-coordinates of these points. So what I'm going to do is set my y equals equation right from the beginning, the original, and put in that 0 for x plus 6, and I find out that y is 6. So that means one of my solutions is 0, 6. Then I use the same equation, but I'm going to use my 4 this time. So I'm going to put 4 plus 6, so y is 10. So that means the other solution should be 4, 10. Now, how am I going to check this in my calculator? Well, you can easily check it by looking at your intersections of the graph. So if you go to your y equals, I'm going to type in both equations as they are. So I have negative x squared, squared, plus 5x plus 6, and then I go to y2 and I'm going to put in x plus 6. When I graph it, I know this is a quadratic, it's a parabola, and this is a straight line. So it's going to cross in two places. So I can't quite see it all, so I need to extend my window, my y-axis, a little bit. So if I take my window, notice the highest y value is 10. If I take that up to 15, I should be good. Let's see what happens. Yeah, I see that now. So I am looking for these values right here, these intersections right here. All right, so I'm going to do second trace, and I'm going to go to intersection. Now, first curve, second curve, three enters, and I have 0, 6. That is what I got for my first point, 0, 6. Now, if I want to know for sure what's this point over here, I'm going to do the same thing. I'm just going to go second trace, and we're going to go to intersect. And this time I'm going to move my cursor closer to the other intersection. Move, 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 enter, 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 boom, there it is, 4, 10. I guess you can't see it because of the glare. But there it is, 4, 10. And that is what we found algebraically. All right, so you can always check your work with your calculator. Let's try another one. Y equals x squared minus x plus 3. So I'm going to take this guy and move it up. So I'm going to have negative 2x plus 5 equals x squared minus x plus 3. I want this guy to be positive, so that means I'm moving all this goodness over on to the right side by changing my signs. So I'm going to do x squared, I'm just going to rewrite this, minus x plus 2x minus 5. Now let's regroup. So I have x squared minus x plus 2x gives me plus 1x. 3 minus 5 gives me minus 2. All right, now I have a trinomial, and I can look to factor this. So I'm thinking two numbers that multiply to negative 2 but add to a positive 1. All right, multiply to negative 2 would be a 2 and a negative 1, and I add them up, I get a positive 1. Yep, I do. Now my leading coefficient is a 1 right here, so that means I can go directly to the factors with these values. X plus 2, x minus 1, and then I'm going to solve. X plus 2 equals 0, so x is negative 2. X minus 1 equals 0, so x is 1. Now I need to find those y coordinates, so I'm going to take that y equation, and I'm going to put in my first x value I found, negative 2 plus 5. So I get negative 4 plus 5, which is going to give me, oh, no, it's going to be positive 4, isn't it? Positive 4 plus 5, which gives me y of 9. So my first solution would be at negative 2, 9. And then let's find the other one. Y equals negative 2 times 1 plus 5. So it's negative 2 plus 5, which gives me a 3. So my other solution would be at 1, 3. Let's check that on the graph as well. So I'm going to put in that first equation, x squared minus x plus 3, negative 2x plus 5, graph it. All right, I can see those two intersections. I'm going to do second trace, number 5. And I'm going to go towards this one on the left. So here's, it's clicking on one curve, hit enter, it will jump to the other curve. Enter, enter, negative 2 and 9. I don't know if you can see, negative 2 and 9. And that's what I got, algebraically, negative 2 and 9. Now if I do the same process, second trace again, number 5, I'm going to scroll over till it's blinking closer to that other intersection. There's one curve, the second curve, enter, enter, and it gives me 1, 3. Sure enough, the other solution I got is correct. All right, let's try another example. All right, so I'm going to leave my lead positive over here. So I'm going to put that x squared plus 4x plus 5 equals negative x squared plus 5. So I need to move these guys over. So x squared plus 4x plus 5. If I move that over, it becomes plus x squared minus 5 equals 0. So now if I combine like terms, I have 2x squareds plus 4x plus 5 minus 5, those go away, equals 0. Now I look to see, can I factor, GCF, whatever. I can take a GCF out of 2x. That gives me x here plus a 2. Now I set this equal to 0, 2x equals 0, so that means x is 0. X plus 2 equals 0, so x must be negative 2. Now I need to go back and solve for the y values using that second equation. So I'm going to do negative x squared plus 5. Well, that's just 0 plus 5. So that y value must be 5. So one solution is 0, 5. Then I do it again with the other x value. Negative 2 squared, so we're going to get that negative in the front, plus 5. So negative 2 squared is positive 4, but times that negative right there makes it negative 4 plus 5. So that y value is a 1. So another intersection I should find is negative 2, 1. All right, let's look at our graph and see what happens. Negative x squared plus 5. All right, great. Let's look at it. Now, notice this is two parabolas opening up this way, so it still has two intersections, a quadratic and can intersect another quadratic in two places. So it's the same idea. Second trace, go to intersect. So if I go close to, let's see, I'm going to do the left side first. So this one should give me, oh, there's my negative 2 and 1. Then I'm going to do the second thing again. Hit 5. Go closer to the other intersection. This one, this one, this one. And I get, so see this negative 5.58 to the e to the negative 15? That's basically 0. Remember, it gets stuck on a pixel in the graph. So when you have that e to the big negative number, that's 0. So there's your 0 and your y is 5. And that's what we got right there. All right, let's try one more. Again, we're going to set these equal. I want to make this part positive, but let's group them first. So 9x plus 6 equals negative 3x squared minus 3x minus 6. So I'm going to move these elements over so that my lead exponent is going to be positive. So I'll have 3x squared positive plus 3x plus 6 plus the 9x plus 6 equals 0. So I'm moving everything over. Now I'm going to regroup. So I have 3x squared. 3x plus 9x is 12x. And 6 plus 6 is 12. Now we're set to do some factoring. I can take a 3 out of each term. So I'll have x squared plus 4x plus 4 equals 0. Now I can factor this. Okay, I want to multiply to 4 and add to 4. Well, hopefully that quickly comes to mind of a 2 and 2. My lead coefficient is 1, so I can just do x plus 2 times x plus 2. That 3 is hanging out here, but there's no x attached to it, so there's no solution with it. I don't have to worry about it. So then I set x plus 2 equals 0. X must be negative 2. So it's a double root, right? It's a double root because it's repeated. So then what would the y value be? Well, let's put it in. 9 times negative 2 will give me negative 12. So it must intersect at negative 2, negative 12. Only one intersection. So let's see what that looks like. And then 9x plus 6. So it's coming way down here, and it's coming way over there. So can't quite see what's going on, but I can hit zoom and out. Okay, I can see what's going on down here, but I also know my y value of the intersection is negative 12. So I'm going to change up my window. I'm going to hit window, and I'm going to make my y minimum like negative, I don't know, 15. And my maximum down to 5, because I'm really interested in what's going on below this. So let's see what happens. So I can see it's intersecting right there. So if I hit second trace intersect, I'm going to scooch over closer to that place where it's touching. And there it is, negative 2, negative 12. Okay? Negative 2, negative 12. So sometimes you have to manipulate your window to make it work. Now, remember, to get back to the regular 10 by 10, just hit zoom 6 and you'll be back reset to the beginning.